All right, so we're going to get to harder u substitutions. So here I'm looking at the inside of the angle of cosine. So I'm thinking that u equal 1 over x will be a good u substitution. So let's be careful here. If I want to take the derivative of 1 over x, I want to think of that as x to the negative 1. So I get negative x to the negative 2. It's the integral of 1 over x that gives me ln of x. So be careful that you know the difference between the integral and the derivative. So this is, the derivative here would be negative x to the negative 2 dx. So that can be rewritten as negative 1 over x squared dx. So I can see that I've got 1 over x squared here, not with the negative. So I think you can see how I can get a negative cosine of u du. Then take the antiderivative and that sine, and then put the x's back in. Sine of 1 over x plus c. All right, so looking at this one, if I did a u equal to 3x, so just thinking, then I would get a 1/3 tangent to the 4th of u secant squared of u, but that's a dead end. I can't do anything with that. So, because I don't know how to take that antiderivative. But what if I thought about the relationship between tangent and secant? Don't we know if I have u equal tangent of x, that the derivative will be secant squared? Oh, look at that. I have a secant squared and I have a tangent. So let's go a little bit further and adjust to what I have. So let me rewrite the problem. So I have tangent of 3x all to the 4th power, secant 3x all squared. Okay, so let's let u equal tangent of 3x. Using the chain rule, I get 3 secant squared of 3x. So I just have secant squared of 3x, so I need a 1/3 here so that I can make the substitution. So I get u to the 4th 1/3 du. So carrying the 1/3 along, adding 1 to the exponent, plus c. I get 1/15th, and then it's tangent of 3x all to the 5th power plus c. All right, so let's look at this one. Same idea. If I just let u equal 2x, it's not going to be enough. But I do notice, right, so if I let u equal 2x, it will lead to, I'd get a 1/2 on the outside. I'd get a sine of u, a cosine squared of u. I can't take the antiderivative of that, so it's a dead end. So let's do the same thing as I did on the other one. Since I see that this is cosine squared, so let me rewrite this. This is the same as saying cosine of 2x all squared with a sine of 2x out to the side. This letting u equal cosine of 2x will be a good idea. So let me get rid of this. All right, so let's start with u equaling cosine of 2x. Using my chain rule, I get negative 2 sine of 2x. So negative 1/2 du will give me sine of 2x dx. So this turns into u squared negative 1/2 du. So carrying that negative 1/2 on the outside, I get 1/3 u cubed. So negative 1/6, and then it'll be cosine of 2x all cubed plus c. All right, so I rewrote this many times already so that you could really see what was going on. So sometimes changing the order of it, so the functions are here beside the dt. Looking at this, I can see that letting u equal the inside of the radical will be a good idea. So letting u equal 1 plus tangent t, and then du will be secant squared of t dt. And isn't that what 1 over cosine squared is? It is. So this turns into 1 over the square root of u du. Rewriting this before I go take the antiderivative is u to the negative 1/2. So I add 1 to the exponent, divide it by 1/2 or multiply by 2 plus c, then put the t's back in. plus c. All right, so same thing with this one. Well, let me stop and finish off these on the next video.